Okay, so if you've ever walked into, say, a massive retailer and seen those gaps on the shelves, you know that frustrating moment when the exact thing you needed is just gone.
Yeah, that's a classic inventory management fail right there.
Exactly. And on the flip side, businesses are dealing with overstocking, which just ties up huge amounts of capital. It's this constant balancing act.
It's the age-old headache for anyone in the supply chain. Stockouts or overstock.
Well, today we're doing a deep dive into the technology that might finally be cracking this problem, moving way beyond just simple sensors. We're talking about this convergence of artificial intelligence, the Internet of Things IoT, and advanced computer vision.
Right. All working together to create these automated replenishment alerts.
It sounds pretty futuristic.
Well, it's here now, and our sources suggest this isn't just a minor upgrade, it's like a complete rethink of how inventory should flow. We're looking at a tech stack that can monitor, analyze, and importantly anticipate and act almost instantly.
So what's our mission for this deep dive?
Okay, I think it's threefold. First, we really need to unpack the mechanics, like how do these pieces actually fit together? Second, let's quantify the benefits. The hard numbers on efficiency and cost savings are frankly pretty compelling.
Got it. Mechanics, then benefits.
And finally, we need to look ahead. How does this shift the future of the global supply chain? What's the bigger picture?
All right, let's start with the mechanics then. Real-time stock monitoring, that phrase, implies almost zero delay.
Yeah.
How do they actually achieve that kind of immediacy? What components make it intelligent, not just sort of reactive?
Yeah, the immediacy is key. And what's fascinating is how these different technologies integrate. It really starts fundamentally with IoT sensors. These could be proximity, weight, maybe even simple motion sensors, physically gathering that raw data on stock levels.
Okay, sensors on the shelf, basically.
Right. And that data gets fed into a central system, often called a multi-channel platform, or MCP.
Hold on, MCP. For listeners maybe not swimming in enterprise software terms, what's that platform actually doing? Is it just a database?
That's a fair question. Think of the MCP as the central nervous system for all the inventory data. It's coordinating stock information across every channel, so if you sell online and in 10 physical stores and from a warehouse.
So everyone's looking at the same numbers?
Exactly. The MCP makes sure every part of the business sees the exact same inventory count simultaneously. It gives that essential context to the raw sensor data.
Okay, context is good. Then what?
Then, once the data hits the MCP, the AI engine takes over. That's the brain, constantly calculating optimal stock levels, safety stock, that sort of thing. And if the actual stock dips below that predefined AI-calculated threshold, bang, it triggers an immediate alert.
So sensors feed the MCP. The MCP centralizes. The AI decides, uh-oh, time to restock.
Yeah.
But you mentioned computer vision earlier. That feels like a really big step up from just reading a sensor. How does visual analysis fit in?
It absolutely is a big step up. And this is where the system gets, well, really accurate. It's not just relying on, say, a weight sensor, which might fail or be off if a product is weirdly shaped or something.
Yep.
Computer vision, often using well-established frameworks like OpenCV, is actively analyzing images or video feeds of the shelves. It's literally looking at the physical layout, counting units, spotting those gaps visually.
So it's like a second check. If the sensor says 10 units, the camera looks and says, yep, looks like 10, or maybe, nope, only 8.
Precisely. It provides this crucial layer of verification and also flexibility. You don't necessarily need a physical sensor for every single item or SKU. If customer just takes the last box off the shelf, the vision system sees that physical gap.
And it can confirm the sensor data, or maybe even catch something the sensor missed. Probably faster, too.
Often much faster and more reliably than just a purely mechanical count, yeah.
Okay, that sounds incredibly data heavy, though. If you've got hundreds of cameras streaming images, analyzing all that, sending it back and forth to some remote cloud server, doesn't that introduce serious delays? Latency. How do these things stay fast?
That is the critical engineering challenge here. And the solution, which the research consistently points to, is edge computing.
Edge computing, meaning?
Meaning, instead of sending all that raw video and sensor data way off to a distant cloud data center for processing, you process it right there, on site, at the edge of the network.
So, in the store? Or the warehouse itself?
Could be, yeah. Processing locally minimizes that latency dramatically.
So the decision-making happens right there almost instantly.
Exactly. It ensures smooth, uninterrupted inventory management, immediate decisions. If you had to wait for that round trip to the cloud every time a shelf needed analyzing,
The alert would be way too late. The customer's already gone.
right. Edge computing makes the whole system truly real-time and hyper-responsive.
Okay, that makes perfect sense. Speed equals efficiency. So now we've kind of unpacked how this complex machine works. IoT, AI, computer vision, edge computing. Let's shift gears. What's the actual ROI? Why are companies investing in this infrastructure? What are the hard numbers?
Right, the bottom line. Well, adoption is really being driven by concrete, measurable results across 4 key areas. The first one ties right back to that speed we just discussed, the effectiveness of those real-time alerts.
Okay.
Because the AI is proactive and
Mhm.
the system is so fast, thanks to edge computing, staff get alerted the moment replenishment is needed, not,
Yeah.
half an hour later after a customer complains.
So less time with empty shelves.
Significantly less. This proactive approach, the sources say, cuts restocking delays by up to 40%.
40%. Wow. Okay, that's a huge reduction in delay. But it only helps if the alert itself is based on good info, right? Which brings us directly to benefit number 2, enhanced accuracy. By bringing in computer vision, the system basically eliminates a lot of human counting error. Imagine doing a manual stock check versus an AI visually confirming the count. Yeah, no contest there.
The research indicates this kind of AI-powered visual monitoring improves overall inventory accuracy by up to 25%. That means your records are consistently reliable. You actually know what you have, where it is, and when you need more.
25% more accurate. That's significant.
Okay.
So it's faster, it's more accurate. But what about the cost? Doesn't setting up cameras and edge computing hardware cost a fortune? Does that wipe out the savings, especially for smaller businesses? That's a really important question, and it's addressed by benefit number 3, cost efficiency. And this relies heavily, again, on edge computing. How so?
Because the heavy lifting, the computation is done locally, it drastically lowers the need for those continuous high-bandwidth cloud connections, and it reduces those expensive, constant remote processing fees.
Ah, so you're not paying for massive data transfers all the time.
Exactly. This change in architecture makes the whole technology surprisingly scalable. It sort of democratizes sophisticated inventory control. It makes it accessible even for small and mid-sized retailers who maybe couldn't afford that huge cloud infrastructure bill before.
Okay, interesting. So faster, more accurate, and ultimately potentially cheaper to operate long term. But what about the people, the staff on the floor? How do they interact with this? Are they just getting streams of confusing alerts on a tablet? No, and that's the 4th critical benefit. Seamless integration. The human interface, it's absolutely key here. The notification comes via what the research calls a co-pilot interface. A co-pilot interface. What does that mean in practice? It means it's not just a blinking light or a generic low-stock message. It provides clear, actionable alerts. So it doesn't just say aisle 5 low, it might say aisle 5 slot 3.
Yeah.
Depletion detected, vision verified. Replenished with 12 units of SKU 456 from storage bay 2. So it basically gives them the mission brief, tells them exactly what to do and where to get it.
Precisely. That clarity ensures the alerts integrate smoothly into existing workflows, improves the operational flow, and it prevents, alert fatigue because staff know exactly what's needed. It feels like a helpful assistant, not just another nagging alarm.
That makes sense. Okay, the mechanics seem solid. The metrics are definitely impressive. Let's zoom out a bit now. Industry impact. Where are these systems really taking hold first? And what are the immediate results for those early adopters?
Well, the immediate impact is definitely being felt across retail, logistics, distribution. Basically, any sector where managing physical goods efficiently is critical.
Makes sense.
And those early movers, they're seeing a pretty substantial and immediate payoff. Fewer embarrassing stockouts, definitely. And also significantly fewer overstock situations where they have to do costly markdowns.
Which leads directly to happier customers, I assume.
Absolutely. Higher customer satisfaction because people find what they want, and just measurably greater operational efficiency all around.
And looking bigger picture, are there projections for how much this could reshape the overall retail landscape?
Yeah, the reports we looked at highlight a potentially massive shift. There's an expectation that by 2025, these AI-enhanced replenishment systems could boost overall retail efficiency by up to 30%.
30%, just for managing inventory better.
Just by managing the what and the when of physical stock movement more intelligently, it really represents a fundamental change in how global inventory could be handled.
Wow, okay, that's a huge economic potential there. So the tech is here, it's working, it's making things much more efficient. If this is the current state, what's next? What's the next evolution for IoT and computer vision in this space?
The really big shift that's underway now is moving the AI from being brilliantly reactive, like alerting when stock is already low, to being truly proactive and predictive.
So moving beyond just analyzing now to predicting next.
Exactly. Future developments are likely focusing heavily on enhancing these predictive restocking models. The AI will start integrating much broader data sets.
Like what kind of data?
Think local weather forecasts, maybe major events happening nearby like concerts or conventions, seasonal trends, even competitor pricing changes, all sorts of external factors.
So it won't just restock because the shelf is empty.
Right. It'll restock because the AI predicts, say, a heat wave is coming tomorrow, and that's going to triple the demand for bottled water in that specific store.
Okay, that sounds like a genuinely smarter, much more responsive inventory ecosystem.
That's the promise. By really accurately anticipating demand and reacting instantly to real-world changes, it could fundamentally improve the entire supply chain and ultimately the customer experience.
Yeah, better planning, less waste.
Absolutely. That move from just managing reactively to truly anticipating proactively, that's where the next decade of efficiency gains will likely come from. It lets businesses allocate capital better, ensures products are there when you, the customer, want them, and helps minimize waste on a global scale.
So this deep dive really showed us how these four pillars, AI, IoT, computer vision, and edge computing, have kind of clicked together for automated replenishment. It's fast, it's accurate, and thanks to that clever architecture with edge computing, it's becoming scalable and cost-effective.
Yeah, the core achievement, I think, is redefining efficiency. We're moving away from waiting for a problem, the empty shelf, to happen before fixing it. We're using all this converged data to anticipate and ideally prevent the problem entirely. It just makes the whole supply chain smarter, more resilient, and that move toward predictive models really does change the game. So, building on that, here's maybe a final thought for you to consider. If AI gets really good at anticipating demand, handling the what, the when, the where of replenishment, maybe even better than humans can, how does the core skill set for a supply chain manager need to evolve?
That's a great question.
What unique human skills become even more critical when the machine is handling all that complex optimization? Something to think about as you watch technology continue to reshape roles across pretty much every industry.